Hello folks, welcome back to my YouTube channel, and we are in the Python for data science module. Our today's topic of discussion is NumPy attributes and operations. Here we will have a look at few commonly used attributes and operations in NumPy. So let's start. First, we will import the NumPy library as we did in our last session, and we will create array. Here I have created two arrays, and then we will check the attributes that are associated with NumPy arrays, right? So here I just run this initial cells, and then we proceed to check all the attributes. So if I do a dot ndim, what does ndim provide us is that it provides us with the number of dimensions of an particular array. So I just will clear this outputs so that you're not confused, and you will see the output each for each and every cell. So a dot ndim, if I write it a dot ndim, it will give me number of dimensions of that particular array. So look at this. When I do a dot ndim, it gives me that it's a one dimensional array. If I do capital B dot ndim, I could easily see it's a two dimensional array. Alright. After that, if I do a dot size, then what size will it give me? I'll just run it. It will give me 5 because there are in all 5 elements. If I do a size of capital array capital B, so B dot size, oh, B dot size, what does it gives me 4. All right, because in all how many elements I have? 4. That's the reason it returns me 4. Now I will go one step ahead and I'll check b dot item size. Now, just make a note what is the difference between size and item size. Now, item size, this depends on the data type and the memory required to store that particular element on depending on what is the data type. Now, if you could see in B, what do we have? We have integers, or in a we have what? We have float values. All right, so it took 8 bytes to store that, and this size is in bytes. All right, if it was a boolean value, that's the reason I created one boolean array. And if it was a boolean value like true, false, and true again, here I created an array. Now if you look at the item size for this boolean array, then you would see the item size is what? 1, because it allocates only 1 byte to for storing the boolean array. Okay. Now moving ahead, a dot shape, this will return the shape of an array. Okay, exact shape. So it will tell you how many number of rows are there, how many number of columns are there. So for a, it is one dimensional array, so we had 5 columns. That's the output that it is showing over here. Now if we do b dot shape, okay, so in b dot shape it will show the output 2 by 2, because B was a 2 by 2 matrix which had 2 rows and 2 columns. Okay. After that, we will um, see what is D type of array A. What is the data type? So we get it as float 64. Please remember what it is showing here is it is showing the data type of each and every element. This total, this whole array is of data type float. That is what it is trying to convey it to us. All right. So that's all about the attributes. Now we jump into the NumPy operations. In NumPy operations, we will have a look at what arithmetic operations are possible. So I've created one array. ARR is equal to np dot array, and I have just passed 3 elements in that. So when I do addition by 10, what will happen? Element wise, the addition will be done, and in every element 10 will be added. Similarly, if I subtract something in every element, whatever I subtract, that subtraction will happen. Similarly, for multiplication as well, only thing is that the operator will change. That is, it will use asterisk, and then for division, also the same way. The thing to show here is element wise it does the operation, and so on. You get the output. All right. After that, I've just created two arrays this time to demonstrate the dot product operation for arrays. All right. So what is when is the dot product possible in first case? If there are 2D arrays, the number of columns in the first matrix should match the number of rows in the second matrix. Only then we will be able to perform dot product. That's the reason for simplicity. What I have done, I have taken A and B as 2D arrays, and I have what I have achieved with that is the number of columns in first matrix. So that is 2 because I have 2 by 2 matrix, and number of rows in second matrix, that is also 2, and that is identity. So for simplicity, I have just kept all the number of rows and columns same so that we can see how this result is achieved. So we have np.dot function by which we can do this operation of dot product. Now if I run this, you will get the output as 19, 43, 1922, 4350 respectively. That means I will just explain a little more on this, the way the calculation is done. Okay, so the way calculation is done is this way. Okay, first row and first column, first row from matrix A and first column from matrix B. Okay, so if you would see here, first row 1 into 5, that is 5, and 2 into 7, that is 14, and 5 plus 14 is nothing but 19. Similarly, again first row and second column. So what is there in first row? 1 into 6, the multiplication position wise, and 2 into 8. So that turns out to be 22, and so on. We get the output 1922 and 4350 in a 2D two-dimensional array as a resultant matrix. Okay, so that's how the dot product operation is carried out. Then we even move further to check if we can do a comparison operator on a numpy array. Yes, we absolutely can, because let's see first what is there in ARR. Is there something that we have defined as a ARR? Yeah, we have 1, 2, and 3 in ARR. Okay, so in ARR, if I do ARR greater than 1, element wise it will compare, as it did addition, subtraction element wise. Here also it will compare element wise, and it will return a boolean array. I say it boolean array because you would see here the array that is returned has only values what, false and true, right? So that is boolean. And then we have some more operations like mean, max, sum. So here I have not run all of those, but I am just showing it that if you want to sum, if you want to do a sum of particular array elements, then you can simply use np.sum and you can do it, and np.mean will give you average of the elements that are there. So the sum turned out to be 6, that is 1 plus 2 plus 3, because ARR was what, ARR, hold on, I will just um, display ARR here. In ARR, we had three elements, 1, 2, and 3. And what is the sum? It will turn out to be 6, and that's what they expected. And mean will give you average, that is 6 by 2, 6 by 3, that will turn out to be 2. So these are few basic operations and frequently used operations, as well as we have also seen what are the attributes that are involved with the numpy arrays. And I hope you have a fair understanding now what are the attributes and the operations of numpy. Having said that, these are not the only operations that we carry out. There may be that you may find some more operations in some textbooks or in some another videos. However, to get started with, I feel these are the most frequently used ones, and that's the one I have shown. Thank you for watching this video, and I will see you in the next video.